Hi, I'm Richard C. I'm a math tutor here at Wyzant, and I'm going to be answering a student question that was sent in, and I'm doing a whiteboard version of the answer because it's very hard to see the answer if you're not looking at a diagram and kind of talking your way through it. The diagram is attached by the student, which makes it a little harder to work with, and earlier a tutor supplied a written answer in words, but I think words and sentences aren't going to work as well here as a whiteboard, so that's what I'm going to use here, and we'll just do a whiteboard lesson. So the first thing I have to do is reconstruct the diagram so that we can all see it and talk about it easily. So I need this. And this is the diagram. Okay, so hopefully you can imagine this circle just touching those. That's pretty close. So I'm just going to start labeling things. This point here is called A. This point here is called B. This point called C. And this one is D. Now the center of the circle is called O, which is the classic name for a circle, circle O. And this point of intersection here is called X. Okay, so there are three parts, and we'll do each part of the question in a different color. So let me change colors. Start with purple. And the first question is, what's the measure, first part of the question, what's the measure of angle ABC? Okay. Well, the thing to notice, I'm sorry, some other pieces of information are given to us, sorry, and I didn't put them in. We're given that this arc is 100, arc AB is 100, and arc AD is 110. Sorry. Now we can do the problem. So let me go back to the purple. Okay, so ABC, you can see, is this angle here. Mark it in purple. And you can see that it's inscribed in a semicircle. Do you see that from A all the way around to C? This arc is a semicircle. AC, arc AC is a semicircle. So that means that this has to be 80. Sorry, 70, geez. 70 here, right? Back here. Put a 70 here. Because this has to be 180 altogether. So we can put a 70 there. We don't really need it right now, but it's good to have it. Why not? And you can see angle B, all of angle ABC here is inscribed in a 180-degree arc. And so the measure of this angle has to be, because it's inscribed, it's half the measure of its intercepted arc. So it's 1/2 of 180. So that's going to be 90. So that's easy to do if you see what's needed. So that's one part of the problem. Now the next part we'll do in another color. And the next part is they want the measure of angle A. Well, it's the same process here. You can see angle A is inscribed in this arc BC. So it's half the measure of angle A is going to be half the measure of arc BC. Well, what is the measure of arc BC? Well, the measure of arc BC is going to be 80 because this arc from A all the way around to C is a half circle. It's 180 degrees. So this arc BC has to be 80. So this is going to be 1/2 80, which is 40. So this first part, the purple part and the green part, are both talking about inscribed angles. And so it's just testing your knowledge that the measure of an inscribed angle is half its intercepted arc. And so you just really needed to find the intercepted arc and then divide by 2. And now we'll finish up in brown and do something a little bit more. Actually, I want something livelier than brown. We'll use blue. And the last part of it is they want the measure of angle AXD. That's supposed to be a D. So AXD is this angle here. Now to see this one is a little bit more sophisticated. We need to realize that we're going to use the theorem from geometry that's called the Chord theorem, which has to do with the intersection of two chords. So I'm just going to make each one of these chords blue so you can see what's going on. Just so much easier when we're doing this on a whiteboard and you can see everything. Okay, so if you look at this angle, AXD, you can see that this is a chord, BD is a chord. A chord is just a line segment whose endpoints are on the circle. So you can see this is a line segment whose endpoints are on the circle. AC is also a chord. It's a special kind of chord. It's a diameter, but a chord is a chord. This is also a chord because it's a line segment whose endpoints are on the circle. Now there's a chord theorem which says this angle, or this one down here, these are vertical angles, they'll be congruent. But this angle, which is the one we're after, is just going to be 1/2 the sum of the intercepted arcs. So that's going to be 110 plus 80 here. Because you can see the arcs of interest here, the 110 arc AD and the arc down here, BC, which is 80. And so that comes out to be 95 degrees. Of course, all these things are in degrees. And that's it. Those are the 3 parts. So as I said before, the first part just is testing your knowledge of the inscribed angle, not the central angle. A central angle is an angle whose vertex is at the center of the circle. Here you can see the inscribed angle has its vertex on the circle itself, on the edge of the circle. So these two are inscribed angles. And then this one, the last one here, was a chord angle. And you just have to, become familiar with all the rules. There are a lot of rules for circles, and you just have to get to know them all and kind of stuff them in your brain for a few weeks until geometry is over. So anyway, that's it for this problem, and I look forward to seeing you again next time. Bye-bye.